Hello student, once again I am Sri. So my dear student of class 8, today we are having new chapter. So in this new chapter we are going to study about the chapter number 7, which is Q and Q root. So first let us see what is Q. We know that Q from the beginning of our math study. In the geometry we have cube. That what is the cube? The cube is the 3D shape of square. Some object or something that is in the square shape. If it is a 3D shape, then it is a cube. Means the square shape, the square object which is having its length, breadth, and height together. These three dimensions, and it is called the cube. Okay. So we here like this. Suppose one square. This is a square. I'm showing in the different manner here. You see. This is square, cube. You got it, cube. Okay, this is a cube. So whatever, this is the length, we don't know x. This is also, this is breadth, we don't know x. This is height, we don't know this x. For example, we know that in the cube, all these edges are same. These edges are all equal. Okay, because all the sides are equal in the square, so all the edge of this cube will be equal. So what happens when we find out the volume of this cube, we just multiply x into x, isn't it? Then we get here x cube. So here you see this number called x cube. So this is what we are going to study, a cube number, a number called cube. So we are going to study about that cube here in this lesson, cube. Okay. So we heard about this cube in geometry. A figure that is called a 3D shape of square, and it is called cube. 3D shape of the square is called cube. So this is the cube. So what happens when we try to find out the volume of the cube? The volume of the cube is the volume of the 3D shape. Okay, the volume of 3D shape cube, it is going to be multiply its length, breadth, and height together. Okay, clear. So whatever the length also its is, breadth also its is, height also it will be is here, and as it is cube or it is a two-dimensional of 3D shape of square, all the side or all the edges will be equal to one another. So I take as edges. Okay, since it is unknown, so we are going to multiply this all three x to get the volume of the cube. So we get here multiplying 3 times the x here. 3 times the x here, x into x, and we got here x cube. So what is the power here is cube. So a number having the power as 3, we say it is cube. So that cube we are going to study in our arithmetic. Okay, clear? Not in the geometry. In the geometry we know this is cube. So in the geometry also we got here the volume as the x cube. So x cube is a number called cube. So it is also now going to study in the arithmetic as a cube now. A number which is multiplying 3 times is called cube. Once again, in the cube you will find that a number is multiplying 3 times. For example, 2. Okay, for 2, if it is multiplying 3 times, then it is called 2 cube. That is 2 to the power 3. It is called 2 cube. Okay, cube. So what is the cube here? Cube of 2. The cube of 2 is 8. 8 is the cube of 2. Means when we multiply 2 into 3 times, then we got 8, and 8 is called the cube number of 2, or a cube number. Or we can say it is a perfect cube. Understand? So let us see some more examples, my dear student. So likewise, so this is called cube. So for example, 3 to the power 3 is cube. This is also cube, or other 4 to the power 3 also cube. This is called 3 cube, 4 cube. Okay, clear? So 3 cube, you will get here 27. So 27 is a cube number. Okay, and 4 you get here for the 16, 64. You get here 4 to and 64. Yeah, this 64 also a cube number, and they are perfect cube. Perfect cube. So let us see again which number are the perfect cube again. Okay, with some other examples. Now, let us take one more example here. Yes, what about so next topic is perfect cube. Okay, perfect cube. So let us see what are the number called the perfect cube. So to find out the perfect cube, let us take one number here, 216. So to find out the the number is the perfect cube or not, we are going to take the we are going to find out the prime factors of this number. We are going to follow the prime factor values. Okay, clear. So let us say that 216, we are factorizing here. So 2 1 is 2, and here 0 and 1 will go here because we take only one is not the remainder, so one we cannot just divide. So when we want to make this one is remainder, we have to multiply with 0. Then one remainder, then we can put 16 together, isn't it? So here 16, then 8. We got here and 2, 2, 5 to 10. Now we can take here 2, 5 to 10. 2 4 is 8. Now still again 2 4 is sorry, 2 2 is 4, and here 7. Now we get here 3 9, and here 3 3. So the number here 216 means to be 216. 216 can be write as the product of its prime factors 2 into 2 into 2 into 3 into 3 into 3, and now we can see here three numbers of the same type are appearing here. Means 2 are 2. The prime factor 2 is appearing 3 times here, and the prime factor 3 also appearing 3 times here, and we can pair them as three numbers of the factors, isn't it? So the number that is 216, in which its prime factor can be paired as three number, is called the perfect cube. It's called the perfect cube. Okay, so like this here, 2 to the power 3 into 3 to the power 3. Okay, then we can write as 2 into 3 to the power 3. That is the prime factor can be grouped into uh, three number itself, isn't it? See here 2 appears 3 times here, again 3 times here, 3 also appear, again 3 times here, and we can group them as a pair of 3 numbers. So if we can pair the factors as a group of 3 numbers, then the number is a perfect cube. This is how we can check whether it is perfect cube or not. Okay, clear? Suppose let us say that 100. Okay, 100. So let us find out whether it is a perfect cube or not. Let us factorize this 100. 100 here by 2, 2, 5, 10, and here 0, 50, and 2, 2, 25. Here we get here, and here now we got 3. 3 we cannot be, it is 5. 5, 5 just 25. Now we get here. So 100 we can write as a product of its prime factor 2 into 2 into 5 into 5. But in this number 100, we got that the prime factors are repeated only 2 times here, isn't it? 2 times. So what happens? This number we cannot pair its prime factor as the pair of 3 number itself, isn't it? We cannot pair because only 2 come out here, or it appears only 2 times only. So what happens? This 100 is not perfect cube. It is not a cube number. We say it is not a cube number. So such number where you find that the prime factors are not able to pair in 3 groups of a number itself is not a perfect cube. But the number where you can find that the factors, the prime factors can be grouped into the pair of 3 times the number itself is called the perfect cube. So this is about the perfect cube. So let's go to the next topic of relation. So my dear student, next topic is the same topic, perfect cube, but here what we are going to discuss is that suppose a number is given, and that number is not a perfect cube, but how we can make it a perfect cube? By multiplying a number to it, So it is somewhat that same way that we have done in square root also, that how to make a perfect square of a given number when it is not perfect square. So here also the same case we can find here, that if a number is not perfect cube, so what number can be multiplied to it, or what number, which smallest number can be multiplied to it, so that the number can be a perfect cube. So let us take one example here. For example, this 392. Okay, let us take this 392, and 392 is definitely it is not a perfect cube. So let us see what number will be multiplied to this number so that it become the perfect cube. So let us see how we can find out that number. So it is the same process that we have done in square root also. So that is, we are going to find out the prime factor of this number first, isn't it? Prime factor. Factorize this 2, 1, and here 9, and here 6. Okay. Then 2, here 9 again, here 8, here 2, 4, 9. Then 3 cannot be now. This 13, so now we take here 7, 7, 49. So now my dear student, you see here 392 is getting the prime factors on this number, isn't it? That means, so whether you stop here or whether you can continue one more here, like this, doesn't matter. Okay, when we get the prime number here, we can stop. Division doesn't matter. So here you see this 392. 392 can be rewrite as the product of its prime factors, isn't it? That is 2 into 2 into 2 into 7 into 7. And in the cube, we understand that we are going to pair 3 of its prime factors, isn't it? Yes. Now 2, we got here 3 of them, but here this 7 only 2, so we cannot call it is a prime, it is a perfect cube. So to make a perfect cube, to become a perfect cube, we need 1 more 7 to be multiplied here. That is, you can just think that if you multiply 1 more 7 here, then the number will become the perfect cube, so that all the prime factors can be grouped into 3. It can be paired into 3 numbers of the same type. 2, 3 times, 7, 3 times. But here you see, when we factorize this number 392, we got only 2 7s are there, 1 more 7 is needed, isn't it? So if we multiply the number with 7, this number with 7, then the number will become the perfect square. So therefore, we need this 7 is to multiply here into 7. Means multiply to the number, isn't it? Multiply to 392, isn't it? That is 392 into 7. Then how much we get here? Let's find out. 392 into 7. 7 to the 14, 1 in hand, 7 9s are 63, 64, 6 in hand, 7 3s are 21, 27. Now this is the number, that is 2744. So 2744 is the perfect cube now. Okay, that means we find out that the smallest number that we multiply to the bigger number, that is 392, to become or to make it as a perfect square is 7. Means 7 is to multiply. So like this we can find out which number can be multiplied, and that number which is not perfect square can make as a perfect square. Okay, so let us go to the next topic. Now, next topic also the same topic, only there is perfect. It is part of the perfect cube, and now we are going to deal about that a number is given there that also not a perfect cube. But this time, by which number if it divides, that number it will become the perfect cube. That we have to see. Once again, just before we are discussing about that, to make a perfect cube, which what number we have to multiply, then we are finding out. Means before we are finding out that by which number, if we multiply, it becomes the perfect cube. Now we are going to find out that by which number, if it is divided, the number, then the number will become the perfect cube. That we are going to find out here. Okay, clear? So let us see, by taking one example, let us take one example, 81. So 81 is not a perfect cube, we don't know. So let us find out the prime factor of this number. The prime factor of this number, let us say 2, 2 cannot be, not at all. 2 doesn't make any sense here because here you can see out, isn't it? Then, my guess when you see here 3, yeah. 3, 2 just 6 and 3, 7 here. 1 here, 3, 9 here, 27 and 3, 3 here, 9. So 81, we can write as 3 into 3 into 3 into 3. Now you see here the first 3 prime factors, now we have to pair in the cubes, isn't it? But you see, only one 3 is there which is unpaired. All the other 3 are paired as the number of 3, group of 3, isn't it? Group of 3 of the number itself we have paired it, and 1 is not paired, 1 is unpaired now. So if we divide this 81 by 3, then we will get the number as a perfect cube. So let us see. So 3 is to divide the number 81. Now, because this 3, if you divide this 81 by 3, which is not paired, only single number is there now. So if it is dividing, if this 3 is dividing 81, then we'll get the perfect cube. That is true. Okay, so let us see. That is 81 divided by 3. How much we get here? Let us see, 81. If you divide by 3, then you will get here, I think 27. 27, and 27 is perfect square. Perfect square. Actually, not square, perfect cube. It's a perfect cube now. 27 is perfect cube. Why? Because 27 is 3 to the power 3. Means the cube of 3 is 3. It's a cube number with a cube of 3. 3 cubes. Okay, clear. So like this, we can find out the least number or smallest number which can divide the number to become the cube, or which number can be multiplied to become the perfect cube. So this is what we have to study in this chapter. Okay, clear. And now let us go to the next topic. So my dear student, the next topic is the last part of the chapter, that is cube root. What is cube root? So what is cube root? So one symbol is that we have used in the square root, that is like this, isn't it? So this is a square root, isn't it? This is a square root. We think this is short square root. So this we call it square root. But if cube root, then we will write 3 is called cube. This symbol is called cube root. Okay, cube root of a number. Understand? So cube root of a number. So let us try to find out the cube root of a cube numbers. Only cube numbers can find out the cube root, but if it is not a perfect cube, then we cannot find out the cube root. We have to make them perfect cube by multiplying or by dividing that we have just discussed. So the symbol here is called the cube root. So we are going to find out the cube root of a cube number. So let us see that there is 1000 here. Okay, 1000. So this 1000, we are going to find out the cube root of 1000. Cube root of 1000. Writing means like this, cube root of 1000. Find the cube root of the number 1000 here. For this, what we have to do is that we are going to follow the same method we did in the other chapter, that is prime factorization. So we are going to find out the cube root by the prime factorization again itself. So let us factorize this 1000 now. 1000, if you factorize this 1000, how much we can receive? 2. Why? 100. 2, 250, 2, 1, 4, 5. And now here we have 5, 5, 2, and then 5. Just a minute. So here, this is not 4, here it is 2, 125, then 5, then we got here 5, 5. So we got here that the prime factors of this 1000 is 2, 2, 2, then 5, 5, 5. So we can write here this cube root. Cube root of 1000 equal to cube root over 2 into 2 into 2 into 5 into 5 into 5. Then we have here cube root over, so we are going to pair 3 of them, isn't it? So it is 2 to the power 3 into 5 to the power 3. Then this cube root and this cube can be cancelled. Then we are getting here 2 into 5, it is 10 now. So the cube root of 1000 is 10. We got it. Okay. So this is what we are having now. So this is how we can find out the cube root of a cube number by prime factorization. Now let us go to the next topic. My dear student, once again here we have the last point and last topic of this chapter to be explained, and after this we'll go for the exercise. Okay, so my dear student, the next topic is the estimation of cube roots. How we can estimate the cube root of a cube number. Cube number will be there, no any other. Okay, only cube number. The number given there is cube number only. So how we can estimate without that long process of dividing, multiplying, or what to say, prime factorization. Without that, sometimes we can estimate the cube of this number. Cube root of this number. This is a cube number. This is a perfect cube, so we can estimate the cube root of this number. What would be the cube root of this? Okay, cube root of this number. For example, cube root of this number, how we can estimate is that, you see my dear student, this number, so what we have to do, take this number 17576 here. So what we have to do, start from the left, and you just group 3 digits. Group 3 digits for cube 3 times. 3. The number 3 is very, very important, basically important number to be considered. So we group 3 digits here. Okay, and take this 7, and another remaining is 2. Okay, then remaining is the remaining only, so remaining 2 digits we get. But first we group 3. If there is more digits, we have to group 3 digits, and we have to find out the number which could be the cube root of the given number. Okay, so first we group this 3 digits. So we have 576. So here 576, you see what is the last digit number here, means the digit in the unit place. The digit in the one place is 6. So what happened? The last digit of the cube root also will be 6. We'll take this 6 as the cube root. So cube root, the cube root will be first, last digit will be 6. Means the digit in the one place of the cube root will be 6, and what will be the digit in the next place, means 10th place. What will be the other digit? This should be in the one place, this will be in the one place. Okay, clear? So let us see what is the other number. For that we have to take the 17 But this 17 you see here, this 17 is, the 17 lies between the cube of 2 and cube of 3. 2 cube and 3 cube. This number 17 is the number between the cube of two consecutive number, that is 2 and 3. That means 8 is the cube of 2, 2 is less than 17, but 17 is less than, what is the cube of 3? The cube of 3 is 27, isn't it? Yes. So 27. So this number 17 is between the 8 and 27, which are the cube of 2 and 3. So 2 and 3 is 2 and 3, cube of 2 and 3. So you take the smaller number here. What is the smaller number here? The smaller number is 2. Once again, 17 we take here and this 17. Okay, we find out another digit. First we have the 3 digit here. So out of this 2 digit, the last digit we take as the last digit or the digit in the unit place. 6 we take. But what about the other digit? That we will take this other group of digit, that is 1 and 7, 17. So we find out that 17 is lying between the number cube 8 and cube number 27. Once again, 17 is lying between the cube number 8 and the cube number 27, which is the cube of 2 and cube of 3, isn't it? Yes. So what happened? Take this 2 and 3, 2 and 3. Take this 2 and 3, and this is a smaller one. Take this smaller number 2. Smaller number 2 will be, then we have here the another digits of the cube root. That's it. So the cube, the estimated cube of this number 17576, that means 17,576. Estimated cube is 26. Okay, 26 is the cube root of this number 17576. Okay. Now we got here 26. So if you can take multiplying these 3 times. So if you get this number, definitely you can. Okay. This is how we can estimate a cube. Okay. Just take this and try to understand. If you have any problem, you can ask to me at any time. Okay. Now with this, let us go to our exercise of chapter number 7, 7.1. So my dear student, question number 1 of the exercise 7.1 is to find out whether the given number are perfect cube or not. Okay, clear? So for that, what we have to do, very simple thing, that we are going to find out the prime factors of the number, and we will check whether we can group the prime factors into group of 3 numbers or group of 3 of the number itself or not. If we can group 3 of the prime factors, then the given number is a perfect cube. This way only we will check. So what we have to do, we have to find out the prime factors of this number given here. So I am showing you here 2 of the questions given in the question number 1, and from there you can find out the other rest also. So let us see. Let us say first of all, Roman number 1 is perfect or Roman number 5 is perfect or not. So let us see. Okay, clear. First of all, we are going to find out the prime factors of this number 216. 216. Yeah, start from 2. 2 1 is 2 0 and 8. Here 2 5 4 2 2 7. Here 3 9 and 3 3. So this can be expressed as 2 into 2 into 2 into 3 into 3 into 3, and we get here that 3 of the prime factors can be grouped 2 3 times 3 times, isn't it? Then this is a perfect cube. 216 is a perfect cube. Now let us check this. For 6,656 is a perfect cube or not. For that, we also have to follow the same method, that is finding the prime factors of the number. by prime factorization. So this is called prime factorization. So we are factorizing the number here. Start from 2 to 2 to the 4 to 2 to the 6 to 2 to the 6 to the 4 to 8 plus 16. Next again, 2 to 1 is 2 to 1 is 2 and 2 6 is 12, 2 6 is 12, 2 4 is 8 here. Still we can continue with this, isn't it? Then 2 again, 2 5 is 10, 2 8 is 16, 2 2 is 6, 2. Then here we have 2 again, 2 4s are 2 2s are 4. Here 2 9 is 18. Here 2 6 is 12. 2 6 is 12. Again with 2. 2 1 is 2. 2 4 is 8. Then 2 is 16. Here 2 3 is 6. Now here we are not able to go with the 2 here because the last digit is 3. Not able to divide by 2, isn't it? Now let us go for 3, whether 3 can or not. Let's check once. 3, 4, 8, 16. 3 and 4, 16. Just once again count at this here. This 2, 5,832. See 2, 2 is 4. Here 4 and 18. 2 9 is 18. 2 1 is 2. Then here 6 like this. Then again we can divide with 2 here. 2 1 is 2. 2 4 is 8. Then 11 2 5 is 10. And 16 2 8 is 16 here. Now still we can divide with 2. 2 7 is 14. 2 2 is 4. 2 9 is 18. And we get here 9, so we cannot divide with 2. So let us take 3 here. Whether 3 can divide or not? 11, 11, 18. Yes, 3 can. 3. 3, 2 is 6. Then 3, 4 is 12. 3 is 9. Still can divide by 3 or not? Check. Yeah, 5, 9. Yes, can divide. Then 24, that means 8. Then 1. Is 81 can divide? Yes. 3, 3, 9. 3 2 is 6, then 7, 3 2 is 7, then we come here, again 3 3 9, okay, then here we come here, 3 3 is 9. So we have got the, still we can carry on, doesn't matter, 3 1. So we finish here the division. So let us see whether we can group all these same number into three numbers of group or not. Three of them. Can group or not? If we can group three of them, then it will be perfect. Otherwise, it will not perfect. Okay. So here with this, here we have the answer of this. That is, it can be written as 2 into 2 into 2 into 2. 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3. 1 2 3 4 5 6. 2 2 3 2 3 2 3 2 3. Okay, so here we can group three of them. Yes. So that means the number given here is also a perfect cube. So these are the answer of these two questions, question number 1 and number 5. So they are all perfect cube. So there will be one question or two questions in this question number 1 which may not be perfect cube. Please find out. If it happens that the prime factors are not able to group in 3, we find only 2 or only 1 which is not able to pair into 3 number of group. Okay, then the number is not a perfect square. That's only you have to find. Okay, with this let's go to next question number 2. Okay. So now here, my dear student, we are going to find out that the given number is not a perfect cube. It is not a perfect cube. Now we are going to find out which number would be multiplied here so that they will be a perfect cube. So let us see the solution of Roman number 1. I'm showing only 1 and 4. The rest you can do yourself. Okay. So look here, we are going to factorize this, isn't it? Yes. In the solution, we factorize the number first and find out and try to find out whether the factors can be grouped in 3 or not. Okay, so here 2, 1, 2, 2. Sorry, this cannot be factorized by 2 at all. Just start with the other number. Yes, 2, 4, 3. 2 we cannot start here, okay? 2 we cannot start this. So 3, 6, 10. 3, this also cannot be, 3 also cannot be. Now 7, let us see 7 can be or not. 7 also cannot be. So once again we have this 3 and 5, 6, 7, 8, 9. 3 can be, never mind. 3. So 3, 7 is 21. Yeah. Then 21, then we got here 3. Isn't it? 21, then we got here 3. 3, 8 24. 21, 24 we can directly divide this by 3, isn't it? 3, 8 24 and 3, 1 is 3. Now next also we can carry on with 3. 3, 2 is 6 and 3, 7. Now next 3, 9 and next we have 3, 3. Then again 3, 1. So these are the prime factors of this number. So let us see whether this prime factor can be grouped in 3 numbers or not. So this can be written as 3 into 3 into 3 into 3 into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now you see here this 3 can group. These 3's can group. 3 numbers only we have to group, isn't it? And here only 2 3's are there again, which is unpaired. It cannot be paired as the 3 numbers of the number itself. We need into 3 groups, isn't it? We cannot group as the 3 numbers. We now group as a 3 number here. So one more we need. One more we need. And if we multiply with 3 here, then we will get the perfect square. What we need here, we need one more 3, isn't it? So one more 3, if we multiply with 3, the number will become the perfect cube. So 3 is the smallest number to multiply. That's all, nothing is there. So we find out the factorization, and the factorization we find that first 3's can be grouped, can be paired for the cube, and only other 2 are there in pair. One more 3 is required. That means 1 3 of that. The 3 is the smallest number to multiply and get the number as the perfect cube. Means to get the number as the perfect cube. So this is the answer. Okay, clear? That means 3 is the number to multiply to make it perfect. So like this, we will find out for this one also. That is question number 4. In question number 4, we have this here 675. Means 675. And let us see how we can find out the number. So 5. So first, let us say 2 cannot be even 3. 3. Yeah, 3 can be 3 to the 6, 3 to the 6, 3 5. Now, next number, let us see whether we can do with 3. Yes, 3 also. Now, 3 can be 3, 7 is 21, 3, 5 is 15. Now, 75. 75 means 12. Yeah, 3 can be 3 to the 6, 3, 5. Yeah? Then 3. 3 cannot be now. Here, so 5. 5, 5. Now, 5. No. So this number we get here like this, and the product of this prime factor, that 3 into 3 into 3 into 5 into 5. Now you see these 3's, they can be grouped, they can be paired as the group of 3 numbers. The number is set here, isn't it? Then here this 5 cannot be paired. This 5 are only 2, so one more 5 is required. One more 5 means if we put here into 5 means what is telling? Multiplying with 5. 5 is the number to multiply the number given here to become the perfect cube. So this is not a perfect cube. Yes, here we cannot pair 5 into 3 times, isn't it? So 3 can be already 3 times. Here we can group into 3. Number 5 cannot be grouped into 3 times, isn't it? So 1 more 5 is required. That means 5 have to be multiplied the number to become the perfect cube. That's all. So 5 is to be multiplied, the smallest number to be multiplied the number, the given number. Okay, so these are the answers of this question number 2. Very simple, like this to find out which cannot be paired. You find out that suppose 5 2 only 2 5 are there, or 1 more 5 is required. That means 5 is the number to multiply. Here also only 2 3's are there and paired, so 1 more 3 is required. 3 is to be multiplied. That's all. Okay, and you can check your answer also for the other questions. Question number 1, 2, 3, 5 are there. Next, we go to the question number 3. Okay. Okay, my dear student, the next question, question number 3, is asking us again that we are going to find out, okay, or to find out, asking us to find out which number, not multiply, sorry, it is to divide. Okay, to divide, to divide, so that the number become the perfect square. See, it's quite lengthy in writing the question, so I'm just giving you your concepts, okay, of the questions. Means what is the question? Is that the question is to find out the number that can be divided so that this number, which is not a perfect cube, can be a perfect cube. Okay, so 81, let us say 81. So 81, we are going to find out the prime factors of 81. The same manner, there is 3, isn't it? 3, 2 is 6, 3, 7, then 3, 9, and 3, 1. So it is here we get as 3 into 3 into 3 into 3. So this first 3 we can pair, isn't it? Then last one, 3 is there unpaired, a single extra 3 is there unpaired. So whatever this unpaired 3 is to divide. If you divide 81 by 3, then you get the perfect square. I mean, perfect cube number, not square, perfect cube number. So therefore 81 is to be divided, okay, divided by 3 to get perfect cube. So 3 is the number. 3 is the number to divide it. That's all. Okay. Likewise, for this 704, let us see. 704. 704. So 2. 6. Yeah, 2 3 is 6. 2 5 is 10. 2. Then next we have here again 2. 2 1 is 2. Then 15, then 2 7 14, here 2, 6 is 12. Again by 2 we can continue. That means how much? So 17 and 16, that is 8. Then 8 here. Then we get here 2, how much? 4 here. Then 2 again, 2, again 2 by 2, 11. Then we get here 11, 1. So the number here can be written as 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 into 11. Isn't it? So like this we can make it as a product of their prime factors, and we can group these 3 2's, again another 3 2's here. We can pair in such a way 3 number of them, and you can see that one number extra, that is 11. So 11 is got as an extra number there, is only one single number, unpaired number there. So this unpaired number have to divide the given number here to get a perfect cube number. Okay, so like this. So the answer is in the solution we have to write that 11 is the number to be to divide, not to be divided, okay, to divide, to divide, to divide the given number, okay, that's all. The given number for what? To get the perfect cube. That's all. Okay. So this is the solution of the question number 3 of number 1 and 5. Other you can do as I'm doing here. Try it. Okay. So please do the remaining questions as your homework or as your just practice and try to solve it if possible in my question. Good. So let us go to the next question, question number 4. Okay, then the next question we have question number 4. The question number 4 is a statement given here. The statement is saying that Parikshit makes a cuboid of plastic or plasticine doesn't matter, it's the same way. Cuboid of plastics, okay, of size 5 centimeter, 2 centimeter, and 5 centimeter. So how many such cuboid will he need to form a cube? See, actually, what cuboid is there? Cuboid, you know that cuboid is the 3D shape of a rectangle. So what happens? Such figure of object, if he bring together and pile together to make a cube, to form a cube where all the columns and rows are equal. Understand once again? So he is having a cuboid with a side of 5 centimeter, 2 centimeter, again 5 centimeter here, so that such cuboid he will group together, bring together to make a cube where the number of that cuboid plastic will have the same number with the rows and the same number in the column also. So let's find out how many of the plastic are required here. So in the solution, you see here the cuboid. We know that the area of the cuboid is 5 centimeter into 2 centimeter into 5 centimeter. So my dear student, this is of one cuboid only. So how many cuboid is required to make the such cube is that? You see here only 2 fives are there, isn't it? Yes. And 1, 2 is there. They are multiplying. So what happened? Here we need 1 more 5. Again, 2 more 2's we need here to make it a perfect cube. See, only 2 5's are there and 2 single 2's are there. So we need 2 more 2's to make it a pair of 3 number the same kind. We need the 3 number of 2. So these 2 2's are or 1 5 is required. They are required to make the perfect. So here by the question we have that for only one cuboid we have the dimension 5 into 2 into 5. That is 2 5 and 1 2. So if we just continue like this 5 into 5 into 5 into 2 into 2 into 2, then they are becoming the perfect cube. Means they will have a perfect cube. Then the number of cuboid plastic will able to make the cube at last. So then, therefore, how many number of the plastic cuboid is required that we will get by multiplying the number here in this bracket. So what are they? Therefore, the number of cuboid of plasticine required is equal to 5 into 2 into 2, that is equal to 5 into 4, that is 20. That means 20 number of such cuboid plastics is required to make a perfect cube set by piling together or by bringing all together to make a perfect cube set. Okay, so how many number of that? Only one is there, isn't it? Of having the dimension 5 centimeter, 2 centimeter, 5 centimeter again, isn't it? So such type of plastic object, he needs altogether 20 of them. So 20 number of the plastic cuboid is required to make a perfect cube. So this is the answer for this question. So my dear student, here comes the end of today's session. So we have learned about the finding out the cubes and cube roots here, and about the number that will divide the number to become the perfect cube one, isn't it? And also we have gone through estimating the cube root of a number also. So this is the end of today's sessions. So with this, I take your permission to leave, and we'll meet again in the next video. Till then, have a nice day. Thank you once again for watching my video. Bye bye.